Okay, so we have basically two things left to do. Today we're going to talk about vectors and some basics with those. And then Monday I will wrap up. We have one section of chapter 8 that we need to cover. And then we're done and we'll start our final review stuff. So that's my rough plan.
Is there a quiz over this?
I'm debating. Most likely I'm just going to nix that and probably put it on the final and not do a quiz. So, doesn't mean it won't be on the final. You will see it again, but I'm probably going to skip the quiz. How many of you will be involved with Ag Festival next Friday? Okay. Alright, so first, we have some new things. Have you guys ever encountered vectors like in physics or anything possibly? So you may or may not have heard of them before. A vector is a directed line segment involving magnitude and direction.
Oh my gosh! That's why he says that. From Despicable Me, he goes like villainy with both magnitude and direction.
Maybe it's because his name is Vector.
Yeah, that's crazy.
Maybe we need to watch Despicable Me now, just because of that.
We need that clip.
Yes.
Oh yeah.
Need to add that in, embed that into my slide here for next year. So magnitude is basically the length, and then direction is like your angle. Vectors, we can have different types of vectors. In one format, you have like a starting point and an ending point, so an initial and a terminal point. Our focus, what we're going to be dealing with, are position vectors. In those, we're just assuming that you start at the origin. And so the vector itself is giving an endpoint. So vectors are typically named with just a lowercase letter, but it's in bold. And it's kind of like an order pair, but instead of parentheses, it has that bracket looking thing. So when we're talking about a vector, I said vector AB. If that's a position vector, it means it's starting at the origin. It's going to point AB. So you would plot AB just like normal. So if it were 3, 5, you go over 3 at 5. So that's your ending point. And the vector, we typically put an arrow on the end. So this is what a vector looks like. The magnitude is the length of this side. And we're given formulas to find these, and they are going to be on your formula sheet, but it's actually not anything new. If I asked you to find the length of this side, and you knew this was point AB, then you would say, okay, I'm going to go over A, I'm going to go up B. How would you find your missing side? Pythagorean theorem, right? A squared plus B squared equals C squared. So if you're solving for C, it's the square root of A squared plus B squared. So that's the magnitude. The notation for magnitude in here is just looks like absolute value bars around the vector. So that's the length. And it's just from the Pythagorean theorem, the square root of A squared plus B squared. That'll be on your formula sheet. The second component is the angle, which, again, the angle really isn't anything we haven't already done. If I had to find the angle in this triangle, drew my vector and turned it into a triangle. If I asked you to find this angle theta using A and B, that's opposite and adjacent. What trig function is opposite and adjacent? Tangent. So tangent is equal to B over A. That's how we find direction. So the direction angle is the angle where tangent of theta equals B over A. So those are the two things that we are going to be finding with our vectors today, magnitude and direction. I'll give you the formulas on the formula sheet, but really it's nothing we haven't already done. Let's look at a problem. I want to find magnitude and the direction angle for vector u equal to 3, negative 2. If I ask for a graph, what quadrant is this vector in? 4, because you go over 3, down 2. So I could ask you to draw it, just a little line segment, but then you put an arrow on the end. So the vector looks kind of like a ray. Alright, the magnitude, if you use the formula, it's just the square root of a squared plus b squared. So we get the magnitude to be 9 plus 4, so radical 13. Direction. We know tangent, if we use our formula, tangent of theta equals b over a, or if you think of it as an ordered pair, we know tangent is y over x. So that's negative 2 over 3. Do we know when tangent is negative 2 over 3? No, so we'll use our calculator. Now, you do have to be careful. Tangent is negative in both quadrants 2 and 4, but which quadrant are we in? 4. That picture is necessary to determine which quadrant. Reference angle, make sure you're in degree mode. So tangent inverse of positive 2/3 is 33.69 degrees. So my angle, 33.69, how do I put that in quadrant 4? 360 minus that. That is 326.31 degrees. So if I give you a vector, can you find the magnitude and direction? The second piece of today is working backwards. If we have the magnitude and direction, how can we turn that back into the vector itself? Okay. So, different ways to think about it. I'm going to put a formula up here. Yeah, every time we look at an angle. Yeah. Okay, so my little side note, I just want you to realize that vectors aren't really all that different than what we've done before. You know, if you are going to talk about an ordered pair on the unit circle, we know that x is the cosine and y is the sine. Right? And that all went back to the beginning. When we first defined SOHCAHTOA, or the definitions, we said cosine is x over r, and sine was y over r. Remember that? So, my angle would be the direction angle. R, in a vector, the radius is the magnitude. So if you have the angle and the magnitude, then you can get the vector. Now your book talks a lot about horizontal and vertical components. All that's meaning is find the vector. So the vector itself can be found by taking the magnitude times the cosine of the angle and the magnitude times the sine of the angle. So vector W has a magnitude of 25.0, or if you're writing your notes and you want to shorthand, that just means the magnitude of W is 25. The direction angle, so theta, is 41.7 degrees. Find the horizontal and vertical components. So all I'm asking is really write the vector. Okay, what is our vector going to be here? Horizontal component, that's just the x. Vertical component, that's just your y. And so all we have to do to get the x, it's the magnitude, which was 25, times the cosine of the angle. To get the y, we do the magnitude times the sine of the angle. So I get a vector 18.7, 16.6. Let's do the same thing from a picture. Is everyone okay with that one? So I have a figure with 3 different vectors. And I want to write each of these vectors in the vector form. Let's talk about so vector u. What is the magnitude? So to get the first component, you do 5 times the cosine of the angle, which is 60. And for the second one, we would do? Since 60 is an angle we know, let's do it exactly. What is the cosine of 60? 1/2, so 5 times 1/2. It's just 5 over 2. What's the sine of 60? That would be a 5 square root of 3 over 2. So that's vector u. Vector v. What's the magnitude? Times the cosine, what's the angle? 180 degrees. What's cosine of 180? -1, so 2 times -1 is -2. What's the sine of 180? And 2 times 0 is... Does it seem reasonable that this endpoint is at -2, 0?
Yeah.
That's what the vector is giving us, the endpoint. You know, this one is at 5/2, 5 radical 3 over 2. So here, I'm essentially asking you to find what's that endpoint. So for vector W, what is the magnitude? Times the cosine, what's my angle? Since we don't know 280, we'll use our calculator for that one. Is that okay? Alright, so if I give you a vector, you guys can draw it. You can find magnitude and direction. And if we add magnitude and direction, we can turn that back into the vector. Okay. Final thing. Short. I think we'll get through the big part for you. Vector operations, we're just going to talk about the basic things you can do with vectors. And even if I didn't teach you this part, you would probably guess it correctly. So if I said I want to do vector AB and add that to vector CD, if I didn't even tell you, what would you guess?
Oh, wait, sorry. That's not
You add the first component, so you do A plus C. You add the second component, B plus D. Just like adding the x's together, add the y's together. The second operation that we can do is we could take a vector times a number, and all you do is distribute that to each component. So let's try a problem with this. You okay?
Yep, I'm good.
One of those where the harder you try not to talk, the worse it is.
Yeah, it was so embarrassing.
So here's vector u and vector v. So if I said u plus v, what do we get? 2, 4. -2 plus 4 is 2. 1 plus 3 is 4. So we get vector 2, 4. If I ask for -2u, what do we get? We have to do two things here. You can do them all at once. I'm going to write it out. So vector 3u, what would 3u look like? Minus 2v. So 2 times vector v, 8, 6. Or you could distribute the negative already if you wanted. So then you just subtract. -6 minus 8 and 3 minus 6. Is that one okay? I could ask you to do a vector operation where I don't even give you the total vector. So you might see something written like this. And all this says is vector u is already a combination of other vectors. It's -I plus 2j, and vector v is I minus j. So all that means is when I do these operations, I'm still going to have i's and j's in them. I'm not just going to get a number. So if I said 2u plus 3v, what would 2u be? 2 times vector u, that's -2i plus 4j. 3 times vector v, so that's 3i minus 3j. So then you just add like terms, so you get I plus j. Okay, so it could be in terms of another vector. Yes?
I just have a question on C before.
Uh-huh.
Where did we get A6 from?
I took vector v, it was 2v as well.
Oh.
Thank you.
Well,
I and J are each vectors
Yeah.
themselves, so we would.
I can't get down to the bottom.
Yeah.
But don't spit it out.
Okay, so v minus 3u. So vector v is I minus j minus 3 times vector u. So if you distribute through negative 3, you get a positive 3i minus 6j. So you get 4i minus 7j. Are we good with vectors?
Yeah.
Okay, so let's quickly grade our homework and then we will